All right, in this video, we are going to solve the following linear system: 3x minus 9y equals 12, minus 2x plus 6y equals minus 4. All right, and in this example, we said, in this example, we're going to actually wind up with no solution. So I'm going to go ahead and tell you what happens. And so, so you can see what happens when you have one of these no solutions. So in the previous videos, we've talked about solving systems with exactly one equation and then infinitely many solutions. We've already done an example of that. And so I haven't given you an example where there's no solution. Okay. All right, so let's see how this would go. All right, so what I'm going to do is solve this one by elimination. Not that it's really set up great for elimination. Remember, with elimination, what you're looking for ultimately, the best thing would be if these coefficients, like the coefficient of y in one equation, is the complete opposite of the coefficient in the other, and or x for that matter, and that just doesn't happen here. 3 and minus 2, negative 9 and 6. It would be better if it was 3 and minus 3 or negative 9 and 9 or something in that situation. So we don't have that. The next best thing in elimination is if one of the coefficients goes into the other coefficient of the same variable in the other equation. So like if negative 2 went into 3 or 3 went into negative 2, which it doesn't, 6 doesn't go into negative 9 doesn't go into 6. So it's not a great one for any of those methods. Okay, so I'm going to use elimination, and what I'm going to do is I am going to have to multiply both equations by a number. All right, so on the top one, I am going to multiply it by 2. And on the bottom one, I am going to multiply the bottom one by 3. And the reason for that, right, is that it will make the coefficients of the x's opposite in the two different equations. So multiplying 3 by 2 will give me that 6x in the first equation, and then multiplying this negative 2x by 3 will give me a negative 6x. And there I have the situation that I want, right? I want these to be opposite of each other. So that's why I pick these particular numbers. Okay. All right, and of course I have to multiply the rest of the terms as well, right? So negative 9y times 2 will be minus 18y. 2 times 12 will be 24. Right, multiplying 2 by 12 here. All right, and then multiplying the rest of the terms in the second equation by 3. I have 3 times 6y will give me positive 18y. And 3 times negative 4 will give me negative 12. Okay, so again, I've set up that situation where these coefficients are opposite of each other. And once you do that, then what you want to do is to add the two equations together. Okay. All right. So 6x minus 6x will give me 0x, right? 0x is just 0, and I'm not even going to bother to write that 0 there. Next up over here, I have negative 18y plus positive 18y, right? So negative 18 plus positive 18 is 0y, right? And so again, that is just 0. And since I don't have anything else here, right, and it just comes out to be 0, here I have to write that 0, right? In other words, all of these drop out, and I'm just left with the 0 right there. All right, and then over on the right side, I have 24 minus 12. That comes out to be 12. All right, so what happens in both the infinitely many solutions case and the no solutions case is that all of the variables drop out. Both the x's and y's drop out, and that's regardless of what method you use. You could have used the substitution method on this, and the same thing at some point will happen. Right? All of the variables will drop out, and if all of the variables drop out, then you can look at this equation and say, yes, that's true, or yes, that's false. In other words, it will be what's called a statement. And this statement, right, the statement that 0 equals 12 is false, right? That's not true. Okay? And so if that's false, then the answer is just no solution. All right, and that is it. That's the end of the problem. Okay, so just recapping the infinitely many solution and no solution case. In both cases, all of the variables are going to drop out, whether you use substitution or whether you use elimination. If all the variables drop out, then you will be able to say whether what's left is true or false, right? In this case, it is false, and so there's no solution, right? If you get a true, then the answer will be infinitely many solutions. Okay, so that is it on this video.